Welcome everyone to 2.3, Evaluating Limits Analytically. This is going to be a long lesson. Very informative lesson. A lesson that is a little bit difficult, but if you get the hang of it, and if you are good at algebra, it is easy. Now, I am also going to increase your algebra skills throughout the lesson, throw in a little bit of review for algebra. Which is good because when you take your entry level exams for college, if you're going to college, or you're going to the military, or you're going to any trade school, you usually have to take a test when you go start off. Always algebra on it, never really calculus, because not that many people take calculus, but always algebra. So it's good for you guys if you are struggling with the other stuff. So anyway, at the end of this, probably longer than an hour. Hopefully you break it into a bunch of pieces because this is like a week of class. Evaluate a limit using properties of limits. Develop and use a strategy for finding limits. Evaluate a limit by dividing out and rationalizing techniques. And evaluating a limit by using the squeeze theorem. So pretty much we're going to evaluate limits and throw in a little trig too. Ready? Got to start somewhere. We're going to start with the basic limit. So what is a basic limit? Well, the limit of something as x approaches something. Remember what we said? The limit of b is your function, as x approaches c. C is what's on your graph line right there. So if you just have the limit of b, where b represents a constant, what do you think that would be? Well, let's look. If I graph 3 on this line, 3 is a horizontal line, right? Any constant is a horizontal line. So what do you think the limit of a horizontal line is? X approaches any number on this line. Go on, yell it out. Come on. It would be b. Okay? It's itself. So the limit of 3 is x approaches 5. Let's look. 5 is on this graph. Right there would be 3. What's the limit of 3 as x approaches negative 5? 3. What's the limit of 3 as x approaches 0? 3. What's the limit of 3 as x approaches 3? 3. 9. 3. Infinity. Whoop. Too far off this. 3. So x is approaching any c here. Your answer is always going to be that constant. You have to be able to remember that. Very important. Next part. The limit of x as x approaches c. X is your function. X is your identity function. So remember the graph of x. Whatever x equals y equals, x equals y equals 3, 3, 4, 4, 5, 5, 6, 6. So as we did before, what do you think the limit of x is as x approaches any number? It is that number. So the limit of x as x approaches 4. Well, when x is 4, what's y? 4. All right. What's the limit of 6 as x approaches 6? 6. The limit of negative 5. Whoops. As x approaches... Wait. The limit of x as x approaches negative 5. Negative 5. The limit of negative 10. The limit of x as x approaches negative 10. Negative 10. All right. Take this and you plug it in for x. Pretty simple. All right, now say we got x to a power. All right, that could be squared, that could be cubed, that could be to the 5th, to the 8th, to the 1/2, all right, to the negative 1/5, anything. All right, so as x approaches c, all you do is take that c, and what do you think you do with it? You plug it in for x. So c to the n. So the limit of x to the 3rd as x approaches 2 would be 2 to the 3rd power. 2 times 2 is 4, times 2 is 8. See that? I could have did the cube graph to show you, but that doesn't matter. Try these 6 problems. Go. Pause. Unpause. So the limit of a constant as x approaches negative 3, the answer would be 5. The limit of x as x approaches 27. Plug 27 in for x, and the answer is 27. The limit of x squared as x approaches 9. 9 gets plugged in for x. 9 squared is 81. Pretty much whatever x approaches, you're plugging into the equation. The limit of 12 as x approaches 0. 12, because there's nowhere to plug this x in. That's why it's the same. The limit of x as x approaches negative 6. Negative 6, and the limit of x to the 4th as x approaches negative 2. Negative 2, make sure it's in parentheses, because any negative number to a even power becomes positive. 2 times 2 is 4, times 2 is 8, times 2 is 16. And there is our answers. We all good? Awesome. Awesome, awesome, awesome. So now we're going to move on to scalar multiplication. Good, we're on slide 350. All right, didn't mean to scare you. Well, you have the sheet in front of you, so you see. The limit as x approaches c of b times f of x. Now, the limit of f of x as x approaches c is L, which is the limit. The limit of g of x, a different function as x approaches c, is k. So these are just two limits. They're just different limits. That's why they're given different names, because they are limits of different functions. So if I take a scalar, scalar is when you take a number and you multiply the whole function by that number. So for instance, if your function was x and you're going to say, okay, what's the limit of 3x? Your scalar would just be the 3, because it's 3 times x. So you just take your scalar, multiply it by that. What do you think you do? You just find out whatever the limit is, and then multiply the scalar afterwards. Let's turn this into easy speak. Take the 2, you plug it into x squared. That's all you're doing. You're taking whatever you're approaching, x is approaching, and you plug it in for x. It's algebra. It's simple substitution algebra. 2 squared is 4, so 3 times 4 is 12. Some are difference. If you take two different functions and you add or subtract them from each other, okay, as long as the x is approaching the same thing in both functions, you just take the two limits independently and you add or subtract them to each other. What are you talking about? I'll show you. Right here, 3x is a function, x squared is a function. Actually, x is the function is your scalar. I'm just going to call 3x the whole function. 3, your scalar, times 4, minus 4 squared. 3 times 4 is 12. 4 squared is 16. 12 minus 16 is negative 4. Once again, you just plug stuff in. All right. Number 3, product. When you take the limit as x approaches c of two functions and you're multiplying those functions by each other, you just multiply the limits of said functions by each other as well. So for instance, the limit of 5x times 6x, 5 your scalar times 3, right? Times 6 your scalar times 3. 15 times 18 is 270. Now, here's the magic of math. What if, I know what 5x times 6x is. 5 times 6 is 30. X times x is x squared. Could you solve it this way, do you think? Well, let's check. If you multiply the two functions by each other in the beginning to create one big function, plug the 3 in. 30 times 3 squared, 30 times 9 is also 270. There you go. So you can do it that way. The only time it would not work is if your answer is undefined. Then you'd probably want to go back to breaking it up and actually separating everything. Got it? Quotient. You got it. The limit over the other limit. So, once again, you solve these as two independent things, and then you combine them together. By things, I mean functions. By functions, I mean, wait, yeah. 6 times 1, 1 plus 3, 6 over 4. 6 over 4 reduces to 3 halves. All right? Because 6 and 4 both are divisible by 2. You cannot divide these by both of these. It doesn't work that way. When you take a limit to a power, okay, I can actually just solve this first and then raise it to the power. So solve whatever the limit is, raise that limit to the power, right here. I plug my 5 in. 2 times 5 is 10. 10 cubed is 10 times 10 times 10, which is 1,000. Now, what if I cube this first? 3 cubed is 8. X cubed is x cubed. And now I plug my 5 in. 8 times 5 cubed. 5 cubed is 125. 8 times 125 also equals 1,000. So you can do it either way. You got it? So, you know the basic limits. You know the limit rules. So now what you know what you're going to do? You're going to solve limits like crazy. All right? Let me give you a theorem real quick. And then we're going to bust out tons and tons of example problems. Always good to have theorems. Theorem 2.3, the limits of polynomial and rational functions. Polynomials, that's the word I was thinking of the other day. Come on saying polygons. Polygon, polynomials, all those used in geometry. Polynomials are when you raise variables to powers. Rationals are pretty much fractions. If P is a polynomial function and C is a real number, real number is pretty much every number, then P of X equals P of C. That's it. All this is saying is just take C and plug it in. It's just like solving for a function. If R is a rational function, should have got it from that, N is given by Rx equals Px over Qx, fraction. And C is a, what's C? Constant or a real number again, such that QC can't equal, what can't this equal? The bottom. Take a domain range. Can't equal 0, because then it'd be undefined. Then Rx equals RC. Right, pretty much PC over, PC over QC. Jumping ahead of myself. Right. The limit of a rational function. So let's look at this real quick. What do you do? Plug the 1 in. 1 squared plus 1 plus 2 over 1 plus 1. 1, 1, 2 is 4. 1 plus 1 is 2. 4 divided by 2 is 2. Doesn't seem too difficult, does it? Not yet. Now, the limit of a function involving a radical. Want more rules? Love rules. So n is a positive integer, okay? The following limit is value. So this is positive. If it's negative, it's 1 over that, so it changes a lot of stuff. So for all C, n is odd. Okay, so what that means is, if n is odd, C could be anything. If n is what? Does this have to be greater than or equal to 0? So odd, this can be anything. Blank, this has to be 0 or positive. Even. Okay? And we're not dealing with fractions either. We're just dealing with straight up integers. All right, so let's look. The cubed root of x as x approaches 125. What's the cubed root of 125? What times what is 125? The answer is 5. Odd. Well, let's look. Now it's negative. What's the cubed root of negative 125? So this says the following limit is valid for all C if n is odd. So what's the cubed root of negative 25? Well, cubed root of 125 is 5. Negative would be negative 5. Now watch. Negative 5 times negative 5 is a positive 25. Times negative 5 is also a negative 125. That's why you can do it with the negatives. Okay? Let's look here. No number here means it's the same as being a 2. Square root of 4 is 2. Square root of negative 4 is, no, not negative 2, undefined. Therefore, it does not exist. Okay, if you have a negative under a even radical, it does not exist. You should get advertising for Gatorade. All right, now, theorem 2.5. The limits of a composite function. F and G are functions such that the limit of x approaches C, g of x equals L. The limit as x approaches L is f of L. So what this means is if you have a function inside a function, you could solve it that way as well. Remember we did f of g. Pretty much what you're doing is you're taking this function and you're making that the limit. All right, so let's look. Limit of f of g of x equals the limit of f of times the limit of f of x approaches c for g of x, which is f of L, because L is the limit. Seem difficult? Not really. Plug the negative 3. That's it. So it just means solve the inside first. 4 times negative 3 is negative 12 plus 5 is negative 7. And then I do my second function second, squared. Negative 7 squared is 49. All right? It just means you can solve multiple functions at the same time. Just put that in. See? A lot of words, easy concepts. Now comes the fun. Do the problems. You good? All right, 11. Negative 3. Plugged in there. Negative 3 squared. 9. 9 minus 10. Negative 1. 2. And if you need more time to do this, please pause and go back. 5 times 2 cubed. 2 times 2. Remember, PEMDAS, parentheses. Exponents, multiplication, division, before addition and subtraction. All right, 5 times 8, 4 minus 1. 40 over 3 cannot be reduced. 4 cubed. 4 times 4 times 4 is 64. Negative 3. 3 times negative 3 is negative 9 plus 2 is negative 7. 2 times 0 minus 1. 0 minus 1 is negative 1. Negative, this might have got you, negative 2 to the 4th power. Negative 2 to the 4th power is negative 2 squared is 4. 4 times 4 is 16, which is positive. And then you have the negative still up front, so your answer is negative 16. All right, because you have 4, 5 negatives, meaning your answer is going to be negative. All right? Straight up algebra, substitution. Going to get more difficult, don't worry. Plug in your negative 3. Negative 3 squared is 9. 9 plus negative 9, positive 9 minus 9 is 0. 2 times negative 5 squared, 2 times 25, plus 4 times negative 5 is minus 20, plus 1. 50 minus 20 plus 1. 30 plus 1 is 31. See, I'm doing these in my head. I don't remember these. I haven't done these in like, not a year, like 9 months, because it's summer. Negative 1 squared plus 1. Negative 1 plus 1 is 0. Plug in negative 1. Negative 1, positive 1. Negative 3, negative 2, positive 4. Negative 5 plus 4 is negative 1. Right? Now, your homework that you're supposed to have done. Take the 1, plug it in. 2 times 1. 1/2 times 1 plus 7. 2 plus 1/2 plus 7, 9.5. Or 19 over 2. Or 9.5. All good. 3 plus 1, 4. Square root of 4 is 2. I think we did one like that. Cubed root. 4 plus 4. 4 plus 4 is 8. Cubed root of 8 is 2. Negative 4 plus 3 is negative 1. Negative 1 squared is 1. Good. Next 4 problems that were the homework ones. Now, the limit of a, 8. As x approaches anything is 8. 2 divided by negative 3 plus 2. 2 divided by negative 1 is negative 2. 1 over 1 squared plus 1. 1 over 1 plus 4 is 1/5. 1 over 2 plus 4. 4.5, or 9/2. Oh, look at that. All right. Do now. Should have done the do now. Limit of a constant, no matter what it approaches, is that constant? Answer is 1. 2 over negative 2 minus 2. Negative 2 minus 2 is negative 4. Negative 1/2. Negative 2. Negative 2 squared plus 9. Negative 2 over 4 plus 9. Negative 2/13. Now this one, this might have got you. Negative 2 times negative 5 squared plus 6 times negative 5. Negative 2 times negative 5 is 10. So you got a negative 10 squared, not negative 10 squared, negative times the positive 10 squared plus negative 30. Negative 100 minus 30, negative 130. All right, moving on. The limits of trig functions. Let C be a real number in the domain of the given trigonometric function. The limit of sine x as x approaches c. What do you think that is? Sine c. The limit of x approaches c of cosine x equals cosine c. You just plug them in. Limit of tan x. X approaches c, tan c. See the pattern? Limit of cosecant x as x approaches c, cosecant c. Limit of secant x as x approaches c, secant c, which is also 1 over sine c is cosecant. Secant, remember, is 1 over cosine. Never understand why they didn't match up the letters. I hate that. All right, and right here, cotangent c, which is 1 over tan c. All right, pretty easy. So when you evaluate a definite integral as a limit, tan 0, right? Now, the key is the calculator has to be in radian. To get your calculator in radian, which you did many times, you have to switch from DRG, you press mode, you go to mode, and DRG, you have to switch over to radian. Okay, depending on what calculator you have, it's different things. Okay, so you have to go from DRG, which is degree, to radian. Probably still already there, but you never know. If you use one of the calculators on the computer, typically they always start in degree for some reason. So, tan 0. 0. How do I get that? Use my computer. If you don't want to use a calculator and you want to use tables or unit circles, be my guest. I'm just not going to go over it. All right, limit of x cosine x, so you plug in pi for both of them. Pi cosine pi equals -1. Pi times -1 is -pi. The limit of sine squared x equals, now, -pi is -3.14. Sine squared x, do you guys remember how to move trig functions? That's the same as sine x, whatever that whole thing is, quantity squared. Okay? So that's the same as sine x times sine x. The reason the squared is put next to the sine and not next outside like here, because if you don't use parentheses and you put it out here, you're going to think your x is squared. That's why they put it next to the sine. It just makes it easier to do. All right? So, right here, the limit of sine x squared. I always rewrite it. You don't have to, but it makes me happier. So the limit of sine 0 squared. Sine 0 squared, remember the sine curve? Sine 0 is 0. 0 squared, all that work to get 0 as an answer. But now, at least you know how to split up your trig function, hopefully. Like I said, algebra is going to be your biggest problem in this class, if you have one with this lesson. All right. Ready? Going over some problems. Tan pi equals 0. Secant 2 times pi, so you multiply 2 times pi, 2 times 0. You multiply that first. Secant 0 is, secant now is 1 over cosine. There is no secant button on your calculator. So the way to do this is, you're going to find out what cosine 0 is, right? And you're going to do 1 divided by cosine 0. Cosine 0 is 1. So 1 divided by 1 is 1. Sorry, no easier way to do it. Sine pi x over 2. Sine 2 pi x over 2. What happens to the 2's? They cancel out. Oh. So it gives you sine pi. Sine pi is 0. Remember the sine curve? Cosine 1 times x. So, 1 times pi over 3. Cosine pi over 3, 1/2. Right? Pretty easy stuff. 3 more. Good. Tangent, 3 times pi, so tangent 3/4 pi. Make sure this is in parentheses. Get -1. Secant, like we said before, is 1 over cosine. So secant pi times 7 over 6 would be secant 7 pi over 6, right? But there's no secant button, so we're going to use cosine. We're going to say 1 over cosine 7 pi over 6. Cosine 7 pi over 6 is -8.6666666666, so we'll just make it like that. -1.15. I probably should have made that a 7, but I don't know why I didn't. It's fine. Cosine 3x 3 pi -1. All right. Trig functions are a lot more difficult than I look. All right, so we're all good? Take it up a level. Functions agree at all but 1 point. Now, here's where we're going to start taking up the level. Everyone can use algebra. Everyone knows how to plug stuff into an equation, all right? If you don't, you really shouldn't be in calculus. So now we're going to move up to a little more difficult. Not the top level, but another level. Let C be a real number and f of x equal g of x for all x not equal to c in an open interval containing c. If the limit of g of x as x approaches c exists, then the limit of f of x also exists, and the following is true. The limit of f of x as x approaches c equals the limit of g of x as x approaches c. So what does that mean? Let's break it down. Let f be a real number and the two functions equal each other for everything except for when x equals c. All right? Now, what that means is pretty much you could take your equation, you can change the way it looks as long as it equals the same answer in the end. It's like saying 2x equals 4x. I know, sorry. Whoa, that's really bad. It's like saying 4x equals 2 times 2x. You're changing the way the equations look, but they're the same equations. Let me get a better one. 7 over 14 equals 1 over 2. They equal the same thing, they just look differently, all right? So in this case, we're going to be using canceling out methods. So this would be like 7x squared over x equals 7x, something like that. I don't have a board to write all my stuff on, so it's a little weird. Let me go to this problem. I don't know why I started off so much. So here's how this works. First rule, plug in c and solve. So all you always do with the limit, I'm always going to plug in my c and solve. 1 cubed minus 1 over 1 minus 1. So 1 minus 1 over 1 minus 1, 0 over 0 is undefined. Oh, shoot. If you can end here, you're set. Now, if you want, you can start making your tables. Tables get really annoying then. You're never going to want to make another one again. All right, no, step 2 is to factor. Can I factor the bottom? The denominator? No. Can I factor the numerator? You can. Do you guys remember how to factor cubic equations? Cubic equations is when you have a cube here and a cube here. X cubed is x cubed. 1 cubed is 1. In case you forget how to factor this, really quickly, x cubed minus a cubed. A is just a number. So for instance, if a was 2, this would be x cubed minus 8. Okay, but in this case it's 1. So x is x, a is 1. So x minus 1 equals x squared plus 1 times x plus 1 squared, which is 1. So this is factoring this. You should know how to factor. Now after you factor, what do you think step 3 is? Very good, you simplify. Now the way to simplify equations is to cancel stuff out. Ooh, they're the same. When something is the same in the numerator and the denominator, they cancel out and they go to 1. So now look at our equation is changed. It's the same exact equation, we just simplified it. Okay, so now we got x squared plus x plus 1. We plug in our c. What's our c? 1. 1 squared plus 1 plus 1 is 1 plus 1 plus 1, which is 3. And that's our answer. So, because we're able to factor reduce and make this thing nice and clean it up and get rid of the stuff on bottom that will make our problem undefined, we're able to find the answer without using a table, without using a graph. Right? Now, here's the strategy. Okay, the book likes to go through strategy, stuff like that. So I'm going to go through this before I go over the next example. So first thing you have to do is you have to learn to recognize. Now I highlighted the important words. What limits can be evaluated by direct substitution? So when you figure out which ones I can just plug in and solve right away, it makes life a lot easier for you. Step 2. So that's substituting c in for x and getting a defined answer. Getting an answer that's not undefined. Number 2. If the limit of f of x as x approaches c cannot be evaluated by direct substitution, this gives you an undefined answer. Try to find a function g that agrees with f for all x other than x equals c. Choose a g such that the limit of g of x can be evaluated by direct substitution. All those fancy words means you factor and reduce your answer to ensure that the denominator is not 0 to give you an answer that's not undefined. Okay, if you reduce it and you still get undefined as an answer, it doesn't help you. Number 3, apply theorem 2.7, the one we just talked about, to conclude analytically that the limit of f of x as x approaches c equals the limit of g of x as x approaches c. G of x right here is your factored and reduced answer, which gives you g of c. And step 4, which you don't really have to do, but if you want to, you can use a graph, Desmos, or a table to reinforce your conclusions, to check your answer. All right? You can probably pop up some tables in the calculator if you want. All right, 40 and 41. Not to solve your answer, to check your answer. Let's look at problem number 40. Ready? First thing you do is you plug in, oh, this should say 0. It should say 0, 0 is undefined. Uh-oh, is my answer wrong? So, anyway. Uh-oh, is my answer 0 or 3? I might have to change this to a 3. I gotta go back and look. Anyway, this one has x approaches 3. So, when I factor this, I can still factor this, I can pull an x out of the denominator, right? When I do that, the x's cancel out. You'll have a 5 over x minus 3. Got it? Now, that is the same as 5x over x squared minus 3. These are the same, right? But we're going to use this one. Why? Because it won't give us an undefined answer. So what you do next is, I take it, the limit of 0 of 5 over x minus 3. Okay, this should have been 0. So my green's just messed up. All right, so 3 divided by 0 minus 3. 3 over negative 3 equals negative 1. All right. So just ignore the green. Pretend these are zeros. You would just get 0, 0 undefined. Everything else is good. I hate when I have little mistakes in my problems. I just check the two. This one. How can we factor? What can we take out of the top? A 2. What can we take out of the bottom? A 3. And you have 3 x's here, 2 x's here, so we can take out 2 x's. So, first off, I plug my negative 2 in. I'll tell you right now, the answer is always going to be undefined. All right, most of them are. So I pull the 2 out of the top. 2 times x is 2x. 2 times 2 is 4. And I pull the 3x squared out of the denominator. This is 3x cubed. This is 6x squared. Now, what can I cancel out? The x plus 2's. Leaving me with 2 over x squared. Now, I'm going to use that. The limit is x approaches negative 2 of my g of x, which is 3x squared. Plug my negative 2 in. 2 over 3 times 4, which is 2 over 12. Divide both of them by 2, and you get 1/6 as an answer. Easier than a table, right? Of course it is. All right, ready? Well, try the next 2 problems. Go, go, go. Oh, 4 problems. This was a future now. All right, first one. Plug in your thing. Cosine 1/2 pi times negative 4. Negative 4, half of negative 4 is negative 2. Cosine negative 2 pi, make sure your calculator is in radians, is 1. All right, next one. B. Plug in your 1, right? One over cosecant. What did we say cosecant was before, though? We said cosecant was 1 over sine. So, since it's 1 over sine, a fraction over a fraction, when you divide by something, you multiply by a reciprocal, so it's 1 times sine over 1, so it's actually sine over 1. So, sine pi equals 0. Problem C. Negative negative 2 over negative 2 to the 4th plus 8. That's positive 2 over 16 plus 8, 2 over 24, which is 1/12. And finally, D, negative 9. Got it? Good. All right, factoring. You guys remember to factor? This drove my classes crazy in the years past. So what I'm going to do really quickly is go over how to factor. Very simple concept that should give you no trouble at all. So, number 1. If you have x squared minus a squared, and this is something we touched on before. So, a perfect square minus a perfect square, it is x minus a, x plus a. Now, how do you find this? What's the square root of x squared? X. What's the square root of a squared? A. So you square root them both. Got it? Square root of x squared is x, right? What's the square root of 9? 3, right? So that's our a. So what we're going to do is we're going to plug in this equation. X minus 3, x plus 3. And that's how you solve a perfect square. Why don't you try B and C? All right, good, you're done. Square root of 100 is 10, x plus 10, x minus 10. And it doesn't matter if the minus comes first or second, you could interact. So it could be x plus 10 times x minus 10, x minus 10 times x plus 10, doesn't matter. Right here, square root of 400 is 20. X minus 20, x plus 20. Not too bad, right? Gotta remember that. Gotta remember the factor. Now, the cubed one, as I discussed before, this is x minus a, x squared plus ax plus a squared. And anytime you see a 1 here, it could be, so that goes off by this. So 1 is always a squared. That could be 1, okay? This could be 1, all right? Doesn't matter. So you're going to take the cubed root of a equals a. So I see a cubed. So let's see, does this have a cubed root? If it doesn't have a cube, you can't do this. So I try to take the cubed root of that, and I get one. It's 8. 8 times 8 times 8 is 512. Way to find a cubed root on the calculator. You have to type 3 if it doesn't actually have the button, and then you type, I think it's something with a little x by the radical sign, and then you type in the number. So that's 8. So, ready? X minus 8 times x squared plus 8x plus 8 squared is 64. That's it. Try B. You tried it. Cubed root of that is 5. So, x minus 5 times x squared plus 5x plus 5 squared, which is 25. All right. Quick review. All right, back to the problems. 42. What do we do? You good? Square root of 1 is 1. So first of all, we plug it in, we got undefined. This becomes x plus 1, x minus 1 over x plus 1. Now, here's a hint. Typically, when you get these problems, whatever's in the denominator, if it's undefined, is probably going to be found in the numerator. Ah, a little, that works with math classes, not in real life, though. So you're going to cancel out the x plus 1s. Now, if the limit is x approaches negative 1 of x minus 1, negative 1 minus 1 is negative 2. That's it. Use our cubed root. Cubed root of 8 is 2. So, first off, we find it to be undefined. You can just do the denominator. You don't even have to do the numerator. So, x minus 2, x squared plus 2x plus 2 squared, which is 4. The x minus 2's cancel out. Now, the limit of 2 is x squared plus 2x plus 4. Take your 2 and you plug it in. 2 squared plus 2 times 2 plus 4 is 4 plus 4 plus 4, which is 12. This one. Remember to factor these guys? Oh, we're going to plug in negative 1. Get undefined as an answer. X plus 1 times 2x minus 3. Now watch how this works. 2x squared, the factors of 2x squared are 2x and x. The factors of negative 3 are negative 3 and 1 or negative 1 and 3. So you have to figure out which set of these things getting multiplied. Add it together gives you negative x. So, negative 3x plus 2x is negative x. The x minus 1's cancel out, leaving you with 2x minus 3. You plug in your negative 1, and you get negative 2 minus 3, which is negative 5 as an answer. Don't worry, we're going to get more into those factorings. All right, 45, 46, 47, go, go, go. Got it? Cubed. All right, undefined, what a surprise, right? X minus 1, x squared plus x plus 1 over x minus 1. X minus 1's cancel out. Plug your 1 in. 1 squared plus 1 is 3. Right here, what comes out of all those things? What can we pull out of the top? Well, it's by itself, so nothing. What about the bottom? You can pull an x out of the bottom. Whoops, sorry, undefined. If I pull an x out of the bottom, I'm left with x plus 2. And now what cancels out in the numerator and denominator? An x. So if I cancel those out, I'm left with 3 over x plus 2. Now when I plug in my 0, because these are the same, right? So another way to do this is to cancel out the x, take 1 out of each one right away. Doesn't matter, you can either pull it out or just take 1 out all the way. I like the second way better. So limit of 3 over x plus 2, plug in your 0. 0 plus 2 is 2. Your answer is 3/2. All right. Breathe. These things get long. Pull an x out. After you factor out, you get zeros. If I pull the x out, they cancel out. Now, you have to leave something on top, so you leave a 1 on top. Okay? You can't just leave nothing on top of a fraction bar. You need a placeholder. So, also what you could have done is cancel 1 out, and that whole thing out. So this leaves you with 1 here and 1 there. Either way, gives you the right answer. So, 0 minus 1 is negative 1. 1 divided by negative 1 is negative 1. Okay. Factoring quadratics. For those of you guys that can't factor, now you'll be able to. I forgot to reteach all factoring for some students. There's about maybe 2 or 3 you guys out of 60 that don't get it, but I want to make sure everyone can do this good, and it's just a good review. X squared plus bx plus c. Okay, when you have plus plus, what you want to do is c is pretty much m times k. So 2 numbers multiplied together give you c. If you take those 2 numbers and you add them together, they give you b. Therefore, you get x plus m, x plus k. What does that mean? Well, let's see. Plus and plus. What factors of 8 add up to 6? And this is only when there's nothing in front of the x besides the 1. 8 times 1, or 4 times 2. Which set of these adds up to 6? Well, 8 times 1 is, we can't do math. 8 times 1 is 8. 4 times, oh, sorry, you have to add them. 8 plus 1 is 9. 4 plus 2 is 6. I'm going totally crazy here. All right, even though this says times, this is just times to get the 8. But when I add it together, that's what it gets. Okay, so technically this should have like arrows, not equal, whatever. All right, so I want the 6. That means I have to take my 4 and my 2. X plus 4, x plus 2. Let's look at number 2. Negative m plus negative k is your b. Negative m times negative k is your c. Okay, so you have 2 negatives multiplying by each other. That's where you get your c from. But then you're going to add the 2 negatives to get b. So what 2 factors of 14 add up to 9? Ready? So this becomes x, oh shoot, I should say minus. X minus m, x minus k. Okay? Which one's this? Quads. This was a new one I made last year. Quad number 2. Alright, I'm going to fix that under colors. Make a little notes for myself. So, 14 times 1, 7 times 2. Adds up to 15, adds up to 9. We're just assuming both of these are negative. I want the negative 9s right here. X minus 7, x minus 2. Alright? Awesome. M minus k, m times negative k. So if you have a minus here, now in this case, m is always bigger than k. So if you have a minus here, you need to multiply a positive and a negative. And then, because this is positive, the positive number has to be larger. So we want what factors of negative 20 add subtract to give you 8. Now the bigger number is going to be positive. So, and then you get x plus m, x minus k. So let's see, factors of 20, 20 times negative 1, because like I said, the positive number is bigger. 10 times negative 2, or 5 times negative 4. Which one of these give you positive 8 as an answer? 20 minus 1 is 19, 10 minus 2 is 8, 5 minus 4 is 1. Right here, the 10 and the negative 2. So it's x plus 10, x minus 2. All right. Last one. Now, in this case, when you have a negative and a negative, once again, you're multiplying a negative number and a positive number together. But when I add them together, the bigger number is going to be negative this time. So factors of negative 16 are negative 16 and 1, negative 8 and 2, and negative 4 and 4. What gives you negative 6 as an answer? Right here. Negative 8 and 2, x minus 8, x plus 2. All right, I hope this is a little bit better. All right, and gives you a little bit of info. All right, if it doesn't, I'm sorry. Try. Right? All right, let's move on. So let's go to number 48 and 49. Now you're going to go to factoring. Good. All right. First thing you do is you plug in -3 over an answer, you get undefined. Factor the top. Negative positive means the answers are different. Positive means the bigger number. 3 times -2 is -6, right? 3 minus 2 is 1. Right here, square root of 9 is 3, x minus 3, x plus 3. Look what cancels out. You're left with x minus 2 over x minus 3. The limit of x approaches -3 of x minus 2 over x minus 3. Plug in the -3 here. -3 minus 2, -3 minus 3. -5 over -6. Negative over negative is a positive 5/6. All right. You okay? Problem 49. Factors of 4 that add up to -5. Because this is a positive, these signs are the same. This is a negative, they're both negative. So this actually is x. Plug in my 4. Oh, wait. Look what happens when I plug in 4. 0 over 5 is 0. Technically, you're done. Now, those of you guys that were too lazy and didn't type in that, okay, I forget a lot of times, and just went right off the bat and factored, you would have got something like that. And look what happens. Nothing factors out. Can you do this and get nothing to factor out? Of course you can. So what do? Well, I just leave it like this, and I have to plug the 4 into all this stuff. 4 minus 4, 4 minus 1, 4 plus 1. 0 times 3 over 5, which is 0 over 5, which is still 0. All right? You don't always get stuff to factor out. You can't factor these out and make a negative here. These have to be exactly the same. The signs have to be exactly the same. Or exactly opposite. All right? Let's see. 50 minutes in almost. Ooh. All right, problem number 50. Ready? Type in -5. This was your... No, this was your homework. This is less problem. Undefined. You can factor out. 5 and times -2. 5 minus 2. Square that is 5. 5 minus 5 plus 5 plus 5. Cancel out the x plus 5s. X minus 2. X minus 5. The limit of x minus 2 over x minus 5. Plug in the -5. -5 minus 2. -5 plus 3. -7 over -8, which is 7 over 8. All right, let me get some light in here. Let's go to the next one. Plug in your 2. Undefined. What a surprise. X minus 4. X minus 2. -4 times -2 is +8. -4 minus 2 is -6. I could pull an x squared out of the numerators. Always try to pull x's out first, or numbers out first. The x minus 2's cancel out, leaving with x minus 4 over x squared. Now I can find the limit. Plug in my 2. 2 minus 4 is -2. 2 squared is over 4, which is -1/2. All right, let's get to the do now problem. Can't factor, perfect square. Plug in your 4, you get undefined. X plus 4, x minus 4. Cancel out the x minus 4s, leaving you with a 1 on top. The limit of x approaches 4 of 1 over x plus 4. Plug your 4 in. 4 plus 4 is 8. You good? What do you do? Plug your 3 and see if it solves. 0 over 0. Always comes out to 0, 0. Isn't that weird? Undefined. Can't factor, but you can factor. This one's a little tricky. 3 minus x over x plus 3, x minus 3. Now, right off the bat, none of these are the same. So am I done? No. What can I take out of the numerator to make it the same as one of the denominators? Anyone? I could rearrange the top. Watch this magic. So, maybe this helps you a little bit better. All I did was switch the position. -x plus 3. Still, not the same. Close. What if I factored a negative 1 out of the top? Can you do that? Of course you can. You can factor anything out, as long as you take them both out. So if I take a negative 1 out, this becomes positive and that becomes negative. Now look at it. No. Ooh, they're exactly the same, which is what I want. So you cancel them out, leaving me with negative 1 over x plus 3. The limit of negative 1 over x plus 3. The limit of negative 1 over 3 plus 3 is 1 over 6. Negative 1 over 6, actually. See that? So you can pull negative 1s or negative numbers out of the numerator or denominator in order to make them match up. That's allowed. Because I never took the I left the negative 1 in there. I didn't take it away. I just pulled it out of these two numbers. Got it? Awesome. Now, here's a fun fact. You guys like fun facts? Square root symbol. First used in the, what century do you think it is? Yellow number. Oh, 16th. Originally written as this thing. This is what it's actually written as a lot of time in like a PowerPoint or a Word document. With no bar over the function. So we just write this and then the function. Now it was chosen. Why do you think they chose that? What does it kind of look like? Looks like a lowercase r. I don't really see it, but kind of. Which stood for the Latin word radix, which means root. All right. So there's your little fun fact. You can tell your friends that, and maybe you'll impress them or not. All right. Anyway, so now what we're going to do is we're going to do our rationalizing technique. This stuff is a little more difficult. This stuff is going to get a little more crazy. All right. So I'm about halfway through so far. So take a breath. I'm going straight through them. 15 minutes. Got about another 50 probably. All right. Square root of x plus 1 minus 1. Step 1. How do you find this limit? Plug in c and solve. So let's plug in 0. If I plug 0 in here, 0 plus 1 is square root of 1, which is 1 minus 1, which is 0. 0 divided by 0 is undefined. Shucks. Step 2. Multiply by the numerator's conjugate. Now, in case you guys don't know what a conjugate is, if it was square root of a function minus a number, the conjugate would be square root of that same function plus the number. All right? If it was square root of a function plus a number, it would be square root of a function minus a number. So the conjugate is pretty much almost like the opposite. I don't know, not opposite. It's instead of adding the number you subtract, instead of subtracting, you add. So let's look. So we have our conjugate. Our conjugate would be up here. So instead of square root of the quantity x plus 1 minus 1, it would be the square root of x plus 1 plus 1. Now, to keep the fraction the same, whatever you multiply the numerator by, you also have to multiply the denominator by. So that comes out to this. All right, ready for the next? Now, how the heck did I get this? What do you think? I used FOIL. You guys remember FOIL? So FOIL works as first, that gives me this, over outer, square root of x plus 1 times 1, square root of x plus 1, inner, negative 1 times square root of x plus 1, and then last, negative 1 times 1 is negative 1. So that's where that stuff comes from. Now, where to get the bottom from? Well, x times the stuff on the bottom is just x times the stuff in the bottom. Now, the reason I didn't multiply it in there yet is we're going to see what reduces first. Now, the next step is, look at this. X squared of x plus 1, negative square root of x plus 1. So when we're going to simplify that, we're going to cancel those out right away. Because they're opposites. They can go away. Now, square root of something times square root of something is just whatever the function on the inside is. So that just becomes x plus 1. And then minus 1 over here. And the bottom stays the same. 1 minus 1 is, cancels out. So you're left with x over x times the quantity of square root of x plus 1 plus 1. X's cancel out, leaving you with 1 in the numerator. So your answer is going to be 1 over the square root of x plus 1 plus 1. Now, it's simplified. This and that are the same thing. You would never really write it like this, though, because you typically don't want radicals in the denominator. Now, let's find the limit. We're going to plug c in here, which is 0, and solve. 1 over 0 plus radical 1 plus 1. 0 plus 1 is 1. Square root of 1 is 1. 1 over 1 plus 1 is 1/2. And we just solved the answer. That's it. Is this difficult? Yes, it's difficult. Only if you don't know how to factor them. Ready to try a pair? Of course you are. To do 53 and 54. All right. 53. Square root of x plus 5 minus 3. Right? Multiply by the conjugate. Plus 3, plus 3. Foil the top. Now, two radicals times each other is just the inside function. Plus 3 times that. Minus 3 times this. Minus 9. All right? These two middle guys always are going to cancel out. X minus 4 times this stuff. Now, x plus 5 minus 9. 5 minus 9 is, guess what? Negative 4. This is why you do it. It just magically comes out. The x minus 4's cancel out, giving you a 1. Not magically, it's math, but magic sounds cooler. 1 over the radical, x plus 5 plus 3. You're going to now find the limit and plug 4 into your answer. 4 plus 5 is 9. Square root of 9 is 3. 1 over 3 plus 3 is 1 over 6. See? Not too terrible, right? What do you multiply that one by? Boop. Good. Square root of x plus 1 plus 2. That becomes x plus 1. 2 square root x plus 1 minus 2x plus minus 2 square x plus 1 minus 4. Bottom stays the same. Middle cancels out. 1 minus 4 is negative 3. X minus 3 over x minus 3 cancels out. That's how we're able to get rid of that being undefined. 1 over square root of x plus 1 plus 2. Plug it into our limit. Plug our 3 in. 3 plus 1 is 4. Square root of 4 is 2. 1 over 2 plus 2. 1 over 4, which is our answer. All done. See? Now, uh-oh. 2 more. Go. Got it? All right. Now you have double radicals. Oh, double radicals. Well, you still do the plus. Now, this times this just equals x plus 5. Plus radical 5, x plus 5, minus radical 5, radical x plus 5. Radical 5 times radical 5 is 5. Middle cancels out. Middle cancels out. 5 minus 5 cancels out. You're left with x is all that's left on top. Over x, x plus 5, square root of that, plus square root of 5. X's cancel out. Now with 1 over square root of x plus 5 plus square root of 5. We're going to plug our 0 in now. 0 plus 5, square root of 5 plus square root of 5. 1 over 2. Notice strategy, it's pretty much 1 over 2 times this number. Almost every time. I don't know if you noticed that pattern. It doesn't always work, but a lot of times. So by that, this should be 1 over 2 radical 2. Now, another way to write this is you would multiply this by radical 5 over radical 5, so you have a radical on the bottom. This would be radical 5 over 2 times 5, which is 10. All right, let's look at this one. Plus, so 2 plus x, radical 2 times radical 2 plus x, minus radical 2 plus x. Middles cancel out. Radical 2 is 2. 2 minus 2 cancels out, leaving with x over x, radical 2 plus x is radical 2. X's cancel out. Plug in my 0. Guess what? 2 plus 0 is 2. Radical 2 and radical 2 is 2 radical 2. Multiply both these by radical 2 to simplify. Get radical 2 over 2 times 2, radical 2 over 4. Right. Which one's a better answer? In my class, I don't care right now. This is probably more efficient, better. Got it? Boom! Alright, let's go to your do not problem. Calculator has to be in radian. Remember that, calculator has to be in radian. So, going back to the well. Limit of sine, negative pi x plus 2. Plug in your 3, negative pi times 3 plus 2. So, this plus 2 is outside. So, you just do sine of negative 3 pi. Okay? And then add 2 to it. Sine of negative 3 pi is 0. 0 plus 2 is 2. This is just your vertical shift. All right, B. If I type 0 in here, undefined. Answer's nope. Answer's not doesn't exist. What can I take out of the bottom and the top? I can take an x, right? X and x cubed plus 3. Cancel out those x's. Negative 2 over x cubed plus 3. Now I type in my 0. Negative 2 over 3. Right? I could take a, let's type in negative 5 real quick. 0 undefined. Okay? So I can take an x out of the numerator, factor the denominator, x minus 5, x plus 5. Cancel out the x plus 5s, leaving me with x over x minus 5. Type in my negative 5. Negative 5 over negative 5 minus 5. Negative 5 over negative 10, which is 1/2. All right? Got it? All right, go to 57. Uh-oh. Oh, this one, not even covering class, but we'll go over it anyway. How do you think you do this? Let's type in 0. Undefined. That's not how you do it. What could we do? How about we multiply it by 4 times x plus 4? Now, why do we multiply it by 4 times x plus 4? Anyone have a clue? Because that way we can add these two things together if we don't have fractions together. Now watch. 4 times x plus 4 over x plus 4 minus 4 times x plus 4 over 4. We just distributed. 4 times x plus 4. Now watch what happens. These cancel out, leaving me with just a 4 minus. The 4's cancel out, leaving me with minus x plus 4. So this is technically 4 minus x, 4 minus 4. Because the negative gets distributed to the x and the 4. What's 4 minus 4? 0. So you're left with negative x over 4x times x plus 4. X's cancel out, leaving me with a 1. Negative 1 over 4 times x plus 4. Will this help us? I don't know. We got to check. Find as the limit approaches 0. Negative 1 over 4 times 0 plus 4. 0 plus 4 is 4. Negative 1 over 4 times 4 is negative 1 over 16. It worked! So how did we find this? We found the, pretty much we multiplied this out to be able to add the stuff together in the numerator. Whatever you multiply the numerator by, you have to multiply the denominator by. Once we were able to simplify that out, we were able to take out the x on bottom. All right, try number 58. Try another one on your own. See if you guys get the hang of it. You do? Awesome. On slide 30 of 50. 3/5 of the way there, 60%. Type in 0. Guess what? Undefined. Not good. What do we multiply here by, do you think? 3 times 3 plus x. The two denominators. 3 times 3 plus x minus 3 times 3 plus x over both those things. And you don't have to do this step. This just helps me show what's going on. Cancel that stuff out. Cancel out the 3's. So you're left with 3 minus 3 plus x over 3x. 3 plus x. Distribute that negative sign to both of them. 3 minus 3 minus x, right? Cancels out the 3's, leaving you with negative x over 3x, 3 plus x. X's cancel out. Negative 1 over 3 plus x. Now we're going to go 0 here. Negative 1 over 3 times 3 plus 0. Negative 1 over 3 times 3 is negative 1 over 9. All right? See? Not terrible. Looks scary because it's fractions and fractions, right? But not so bad. All right. Now we're going to go to, I guess, okay problems. Just making sure my recorder's still recording. All right, squeeze theorem. If h of x is less than f of x is less than h of g of x for all x on an open interval containing c, except possibly c itself, then the limit f of x exists and is equal to... What does this mean? The limit of h of x, limit of g of x, equal each other, equal L. You have a graph here, okay? What happens is if I take a function above that graph and below that graph, I can find out where these functions meet And even if it's undefined at that point in the graph, I can find out that point by equating these two functions to each other. Now there is a big, long proof on how this works. Tried to teach for many years and everyone falls asleep, zones out. I get bored of it myself. Let me just explain to you how it works. You can always look this up online if you're really interested in it. The limit of 0, sine x over x. You would think would be doesn't exist because 0, anything over 0 is undefined. It's actually 1. How is it 1? We squeeze it to be 1. We change a bunch of trig stuff around to make it 1. The limit of 1 minus cos x over x, x approaches 0. You would think it's undefined. It's actually 0. How do we get that? We take a bunch of trig stuff, we manipulate it, and we squeeze it to get 0. All right? Sorry, that's just how it is. Like I said, go look in the book if you're interested. Now, what we're going to do is we're going to apply the squeeze theorem. All right? Not define it. So, if you could take this formula and apply it to there, you're good. Now, what this means is if you could take a sine x, and this is only when x approaches 0 for both of these. If x is approaching another number, you cannot use this theorem. Now, I look for a sine x over x in here. Is there anything I could pull out of this equation? Yes. There's sine x over x in that equation, right? This is 5 times x. So if I just take sine x over x and I separate it from the 5, like 1/5 times sine x over x. These all equal the same thing, right? Well, what does sine x over x equal? 1. 1/5 times 1 is 1/5. And that's it. That's how you do these problems. Now the key is you want whatever is inside the trig function, the function in the function, to equal whatever is the denominator. In this case, they both equal x. This part, I'm looking for a 1 minus cos x over x. Do I see it? Yes, right here. It's 3 times 1 minus cosine x over x. So I could separate these two. I know that this, every time as x approaches 0, is going to be 0. So 3 times 0 is 0. Once again, the squeeze theorem is not overly difficult to apply. Now, say you have a limit involving a trig function. Now we're going to use tangent here. Tangent is sine over cosine, right? Because right now, tangent x over x would be 0, undefined. We don't want to be undefined, though. So let's try to manipulate this to get an answer. So I say, okay, the limit as x approaches 0, sine x over cosine xx. Keep going. See if you can do it on your own. Fraction over fraction, the cosine jumps to the bottom. Because if you have a fraction over a fraction, it's the same as a over b times 1 over c. So it's a times b over c. A times b times c. A over b times c. A over b. So it's sine x over x times cos x. Okay? Got it? Look what I take out. Sine x over x equals 1, right? Sine x over x. Do you see it? So that would be sine x over x times 1 over cosine x. Cosine 0, so it's 1, automatically becomes 1, times 1 over cosine 0. Cosine 0 is 1. All right, here's your cosine curve. At 0, cosine is 1. If you want to go to curves, you can also use a calculator in radian. So 1 over 1 times 1 is 1 times 1, 1. See? Not that bad, right? All right, let's go to the next one. This one, a limit involving a trigonometric function. Now, in this case, sine 4x, the 4 is inside the trig function. So that means I have to get a 4x on bottom because they have to match. Now, how do I get the bottom to have a 4x in it? You can multiply the numerator and denominator by the same numbers, remember, because that multiplies it by 1. So you need to match the inside of the trig function with the denominator. 4x has to match down here, so to make this a 4x, I multiply the top and the bottom by 4. Now, sine 4x times 4 is not sine 16x. This becomes 4 sine 4x, because you can't multiply into trig functions, that's not allowed, over 4x. Now watch what happens here. Sine 4x over 4x equals, right? 4x, 4x with a 4 on the outside. So I'm going to take this, and I'm going to separate it from the 4. What does this become? 0. 4 over 1 becomes, this becomes 1. 4 over 1 becomes 4. as it approaches 0. 4 times 1 is 4, and that's it. All right. Let's go do some do-nows. Do-nows, do-nows, do-nows. Oh, this goes back to the beginning of the chapter. 12. Limit of a constant as x approaches any number is a constant. That hammered home yet for you? This has to match this, so what do I have to multiply the numerator and the denominator by? 2. If I do that, you get 2 sine 2x over 2x. Sine 2x over 2x becomes 1. 2 times 1 is 2. Back to the top. Factors of 8 that add up to 6, 4 and 2. X plus 2, x minus 2. Cancel, cancel. Plug your 2 in. 2 plus 4, 2 minus 2. Oh, great. 6 over 0 is undefined. Uh-oh. How do we mess up? Well, since it's still undefined even after I reduce it, answer is D and E. Does not exist. The limit is not going to exist. If you don't believe me, make a table and check. Got it? Awesome. This is a negative 2. It would be set, but it's not. All right, let's do some more of these. This is going to be your homework. But this was your homework, so I went a lot out of order. Okay, do that x squared. Here's your hint. I can actually split up this x squared. I can make this sine x 1 minus cosine x over x times x. Does that help us? How? Sine x over x, 1 minus cos x over x. Each one of these gets 1. Because you can multiply across the top and the bottom to get this back. 1, 0, 1 times 0, 0. That's an easy one. All right, 64. Oh, my back started again. All right. Sorry, I need a little stretch. Theta approaching 0. Same thing as having an x there, doesn't matter. If I plugged in 0 right away, I would get undefined as an answer. So I turn tangent into sine over cosine. Look what happens to these cosines. They cancel out. Because this cosine technically goes to the bottom. Cosine over cosine. You're left with sine theta over theta, which is the same as sine x over x. As x approaches 0. Same thing. It doesn't matter what variable this is. Answer is 1. That was easy. Ready for problem 65? Boom. Alright. Remember what I told you. Sine squared x equals sine x, which is sine x over sine x. So, boom. Split that up. That's the same as sine x squared over x, which is sine x, which can take this x on the bottom, times sine x. Sine x over x is 1. What is sine of 0? Here's your sine curve. 0 is right here. Sine of 0 is 0. Got it? All right. Tan squared x. So that is tan x squared. Tan x times tan x, which is the same as sine over cosine x. So all you have to do is absorb this x with one of these guys, right? Because as soon as we take it off, that x, then we can put a 0 in. Sine x, both these cosine x goes to the bottom. Following still? Hopefully you are. We can take a sine x, absorb that x, and we're left with sine over cosine squared x. This becomes 1. And now you get sine 0 over cosine 0, cosine 0. Sine 0, as we said before, is 0. Cosine 0, though, is 1, which is good. We can have zeros in numerators. We can't have zeros in denominators. So we got 1 times 0 over 1 times 1. 1 times 0. 1 times 0 is 0. All of this just to get a 0. All of this just to get a 0. Is your answer 0 a lot? I wouldn't say a lot, but it is more than often. Ready for the next two? More difficult coming up. Level up. 67, 68. Now you're going to have to really manipulate some stuff. Here's your hint. Cotangent cosine over sine. So let's go. Cosine x over cosine x over sine x. Now the sine x is going to pop to the top. Okay? And then the cosine x, sine x over cosine x. Now watch what happens here. Cosines cancel out, leaving you with sine x as x approaches pi over 2. Now notice this isn't 0, so we don't need to use a special equation. But cosine pi over 2 actually is undefined. There's an asymptote there. So sine pi over 2 is right here. The answer to that's actually 1. I like using these graphs right here sometimes just because easier than a calculator. If you're given pi over 2, pi, 3 pi over 2, 2 pi, those ones we know. Then you get some other ones in between, like a 6, stuff like that, 7, 8. We get radical 3s and radical 2s. A little more tricky. All right, now this one, we want the inside of 3t to equal 2t. So what are we going to do? How do we get this to be a 3t? Anyone? You multiply both by 3 still. So you're left with 3 sine 3t over 6t. Now what do we want on bottom now? A 3t. So 3t times what equals 6t? How can we split this to get a 3t and a 2? 2 times 3 is 6. So now you're left with these two numbers and sine 3t over 3t because it's approaching 0. That becomes 1. 3/2 times 1 is 3/2. See? Little trig fun for you. All right, let's go do some more trig fun. You can take a 5 out of the top, right? Leaving you with, actually it would have to be a -5 because we want +1 minus that, good. And then we take the 2 out of the bottom. -5/2 times 1 minus cosine x over x, which equals 0. And the answer is 0. Got to get a 5t on bottom, so when we multiply by it, 5 over 5. So 5 times sine 5t over 15t. This splits into a 3 and a 5t. That becomes 1. 5/3 times 1 is 5/3. Right? Whew. How you doing? Me too. All right. Do now. 23, 2.3f. Oh, we get some trig fun here. We got to get a 1/3 in here. So how do we get a 1/3? Multiply the numerator and denominator by 1/3. Why couldn't you multiply by a fraction? So 1/3 sine 1/3 x over 4/3 x. So 1/3 times sine 1/3 x, 4 times 1/3 x. You never really have to put them together. You can always leave them separated. What does this become? What does that become? It becomes 1. 1/3 divided by 4 is 1 over 4 times 3, which is 1 over 12 times 1, which is 1 over 12. Good. Now, if you messed it up first time, try it again with this one. Got it? You should have gotten it. This is good to do now anyway. All right. 1/5 over 1/5. So you got 4/5 sine 1/5 over 3/5 x, right? So you're going to have a 3 times 1/5 x on the bottom. 4/5 divided by 3 over sine 1/5 over 1/5 x. These become 1. 4 over 5 times 3. 5 times 3 is 15. 4/15 times 1 is 4/15. There you go. Experts. Doesn't it feel good to be an expert at something? Hopefully an expert. All right, now we're going to do a couple more. Tons of these, okay? Why do we do so many? Well, there's not really many on the test, but I really want you guys to be able to manipulate this stuff. We probably didn't go over most of this in class, so this is extra work for you anyway. All right, almost done. Wow. Take out sine x over x. What does that equal? 1. 5 times 1 is 5. Got to get the bottom to be a 2. Multiply by 2 over 2. 2 sine 2x over 2x. What does this become? 1. 2 times 1 is 2. Multiply this by, once again, 2 over 2. 6. 2 times 3 is 6. Sine 2x over 2x, which becomes 1. 6 times 1 is 6. Yes, it's pretty much just this times this number, okay? I know you're going to say something or think about something like that, but you are correct. All right, this one is going to involve some heavy manipulation right here. Tangent is sine over cosine. So this is sine 2x over 2x. And this is 3 times x over x. Step 1. Cancel these out. Cancel those out. So you're left with 3x over sine 2x. Now we're going to kind of cheat. We're going to deal with reciprocals. I don't want this to be a 3x. I want this to be a 2x. So I multiply by 2 over 2. And you get 3 times 2x. I split it up over sine 2x, right? Because this is a 6x. That matches up. It gives you a 1. So 3 over 2 times 1 is 3 over 2. Did some heavy cheating there. I don't think you're not supposed to play with the equation like that, but shh. All right. Problem number 75. What do you take out? A 7 on the numerator. This right here is 0. 7/5 times 0 is 0. All right. What do we multiply this by? Sine 5 times 0. Sine 0 is 0, so we can't have that. But we can multiply this by 15x over 15x. Now, why did I pick 15x? Why do you think? 3 times 5 is 15. So what you get here is, watch how this works. We want a 5x on top, right? 3 times 5x. So that's going to match up. And we want a 15x on bottom, 3x times 5. So every 3x is matched up. Separate those, match them, and match them. So 3/5, 1, 1 over 1 is 3/5. See that? Was that really hard? I know it's the same as just those two, but this is mathematically how you solve it. All right. Secant's 1 over cosine, tangent is sine over cosine. So x, 1 over cosine 3x, sine 3x over cosine 3x. Now, what happens here is this and this are going to cancel out because they're both fractions within fractions and they're both denominators within denominators. You can move them and cancel them if you want. Move it x over sine 3x. I need this to be a 3, so multiply it by 3 over 3. 3x over 3 sine 3x, right? Got it? That right there is 1. 1/3 times 1 is 1/3. All right. Awesome. 78. Ooh, can we get make an hour and a half? Tan 7x over sine 3x. How are we going to do this one? Tan is sine over cosine. Sine 7x over cosine 7x over sine 3x. Sine 7x, put the cosine x in the numerator. I'm going to actually pull the cosine x out, 7x out, because cosine 0 is 1. So this will just become 1 anyway, which is okay. This is the problem. So I have to multiply this by 7 times 3 is 21x over 21x. So this is going to be a 3x times 7 on top and a 3 times 7x on bottom. So I have this pulled out still. I match up the 7 over 3. I match up the sine 7x over 7x and the 3x over sine 3x. Cosine 0. This becomes 1. This becomes 1 over 1, which is 1. This becomes 7/3. 1 over cosine 0 is 1 over 1 times 7/3. Like I said before, times 1 over 1 times 1. 1 times 1 times 1 is 1 times 7/3 is 7/3. Right. 79. Go, 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 go. Told you, long chapter. Multiplied by 7 times 5 is 35x. 5 times 7x times 7 sine 5x. 5x times 7 times sine 7x. You can group them if you want. 5 over 7 times 1 times 1. is 5 over 7. All right. This one, need a 12x on top, 2x on bottom. So we multiply by 12x. You say, why? Why not 24? You could do 24, but then you're going to reduce later on anyway. Watch how this works. So I'm going to leave the 12x by itself on top, and 12x is the same as 2x times 6 on bottom, right? So 3 times 12x, which already matches up. 2x times 6 is 12x, and I have to keep my negative. And look at matches, matches, stays. Matches, matches, 1, 1. Negative 1/2, 3 divided by negative 6 reduces negative 1/2 times 1 is negative 1/2. Right? That concludes the trig section, and the last couple slides are going to involve word problems, in particular, physics problems. All right, we got, what do we got? 2 more problems left? Let's see, 81, yeah, 2 problems. Each problem is a half page though. So. 81. Whew. You doing good so far? You learning? I hope so. All right. It's a beautiful day outside in here teaching you guys. All right, so, and it's the summer right now, technically. Actually, it is. So, use the position function s of t equals negative 16t squared plus 500, which is the height m, height in meters, of an object that has fallen from the height of 500 meters. So A, if a construction worker drops a wrench from the height of 500 meters, all right, how fast will that wrench be falling after 2 seconds? All right, you ready for that? You got it? Let's see if this works. If the velocity t equals a, seconds is given by the following. The limit of s of a minus s of t as t approaches a, over a minus t as t approaches a. So what is this acceleration after 2 seconds? Acceleration equals time. So at 2 seconds, the acceleration would be t equals 2. Right? T, time, is variable. It can change. So how would we represent t? With a t. Okay. So the first thing you want to do is find s of a. Okay? At 2 seconds, what is the position? Now the way you do this is it's just a function. You're going to take your 2 and you're going to plug it into the equation. So s of 2 means wherever I have a t, in this one place I put a 2. Negative 16 times 2 squared, negative 16 times 4 is negative 64, plus 500 is 436. 436 what? Meters. Okay, I'm just going to leave out the units to the end. Now, s of t. S of t is represented, what is the position at any time t? Do you guys know how you would represent that? How about this? With the actual equation, s of t equals. That was easy. We're going to plug it into our equation now. S of a, which is 436, minus s of t, which we just said, negative 16t squared plus 500. All right, this is also almost like derivatives in a sense. A, which is 2, minus t, which is t. Now what do? Solve. Distribute the negative. That becomes positive. That becomes negative. 436 minus 500 becomes minus 64. What can I take out of this? 16? Yep. If I take a 16 out, I'm left with t squared minus 4. I'm going to take these two. Remember what I said earlier, about an hour ago? You can rearrange these. Negative t plus 2. Now, why would I rearrange these? I want this t to be positive. So first off, how can I factor t squared minus 2? T plus 2, t minus 2. This is neither, right? So how can I make this a t plus 2 or t minus 2? Take out a negative 1. So t squared minus 2, minus 4, t plus 2, t minus 2. Since this doesn't match either, if I pull the -1 out, this becomes positive, this becomes negative. Now, what should I have? They match. And I can cancel them. And that leaves me with 16t plus 2 over -1. All right? Which is the same as 16 divided by -1, -16 times t plus 2. So now I can plug my 2 in. -16, 2 plus 2, whoops, -16 times 4, which happens to be -64. And now I'm going to put, and you get 64 meters per second. The reason it's negative is because the wrench is falling. It's not going up in the air. So the negative means it's going down. All right, let's go to the next part. Now, the worker drops the wrench from a height of 500 meters. When will that wrench actually hit the ground? Now, think of it this way. I don't know if you can see it, but the table under this TV is about 1 meter from the stick right here. So say my S of t, my S of O, my original height, right, when t equals 0, is 1 meter in the air. Say I drop this. How many meters is it in the air after I drop it? 0. So your S of t is 0 when anything hits the ground. All right, so that equals the original equation, which is -16t squared plus 500. Okay, good. Now what you're going to do is you're going to solve for t. You add 16t squared to both sides, you divide both sides by 16, and you take the square root of 31.25, which is about 5.6 seconds, okay? So that's how long it takes for my wrench to drop from 500 meters in the air to hit the ground below. Now, what velocity does it hit the ground at? So now we have to go back to that original limit equation. The limit now is t is approaching 5.6 because that's the time it takes to hit the ground. So now we can find the velocity based on this. S of a minus S of t over a minus t. So S of a is what? What was S of a? That's the height of the ground. And what did we say the height of the ground was? We said the height of the ground was 0 feet high, right? That's how high the ground is, 0 feet off the ground. Your A is equal to t, which is 5.6 seconds. That's your time after hitting the ground. T is approaching it. Got it? So now we're going to plug this stuff in. S of A is 0 minus S of t, which is our equation, over A, which is 5.6, minus t, which is our variable. Once again, distribute the negative sign. 16t squared minus 500 over 5.6 minus t. I can pull a 16 out of here. I'm left with t squared minus 31.25 over 5.6 minus t. Now you may go, oh, that's a decimal. It's not going to square to that. It's not going to go to anything. But look it up here. If I have 5.6 and I square it, I get 31.25. So the square root of this is 5.6. So this is t plus or minus 5.6. T plus 5.6, t minus 5.6. If I rearrange these and I pull out a negative sign, -1 times t minus 5.6, t minus 5.6, cancels out. So now the bottom can't be 0. 16 divided by -1 is -16 times t plus 5.6. -16 times 5.6 times 5 plus 5.6. -16 times 11.2. And that gives me 179.2 meters per second. All right. So this is how fast the wrench is going. When it hits the ground, it's going down at 179.2 meters per second. Pretty fast. Wouldn't want to get hit by that. That is very, very fast. All right? That's like a football field and a half. More than that. Like a football field and 3/4 in a second. Whew. Fast. All right. Anyway, let's move on to problem 82. You guys are going to do this one on your own. Again, good. You should be done. Last problem of the day. Yes. Let's go. A is t. T is 3. T is t. All right. So my constant at 3 seconds. And A, sorry, isn't acceleration. A is just the time. All right. I don't know why I said acceleration before. That was misspoken. All right. So A is just the actual time at that time. All right. Take your 3, plug it in. S of 3. 3 squared, -4.9 times 9, -44.1 plus 200. 155.9. So after 3 seconds, falling 3 seconds, it's 155.9 meters. So look at it, almost hitting the ground. This one's different. This is only 200 feet here. S of t, the original equation. A way to find the height too is always just look at this. Whatever number has no variable attached, that's the initial height. Plug in your S of A. Plug in your S of t. Plug in your A. Plug in variable t. Ready? Distribute the negative. So far I got it all right, right? Doesn't that feel good? Subtract the 2. 4.9t squared minus 44.1. Rearrange these, negative t plus 3. Pull out a 4.9, leaving you a t squared minus 3. T squared minus 3 is t plus 3, t minus 3. I can pull a negative out of here, negative 1. This becomes positive, this becomes negative. I can cancel these out. Leave with me 4.9 times t plus 3 over negative 1. 4.59 divided by negative 1 is negative 4.9 times t plus 3. And now I plug in my A. All right, which is what t is approaching. 3, negative 4.9 times 3 plus 3, negative 4.9 times 6 is my answer, negative 29.4 meters per second. So that's how fast it's going after 3 seconds. Right? Now, if construction worker drops it from the height of 2, when will it hit the ground? Remember, the ground is S of t equals 0, right? S of 0 is your initial. S of t equals 0 is ground. All right, so negative 4.5 t squared plus 200 equals 0. Add 4.9 t squared to both sides. Cancels out over here. Divide by 4.9. Square root is 6.4 seconds. All right. It takes a while. Even though it's shorter distance, it's not going as fast. As t is approaching, 6.4. S of A, what did we say that was? What's S of A? Your initial position. Your position after hitting the ground, 0. S of t equals S of t. And your A equals 6.4. 0 minus equation, 6.4 minus t. Distribute the negative, 4.9 t squared minus 200, 6.4 minus t. All right. Pull out 4.9. Where you at? Square root of 40.8 is 6.4, which matches here, which is good. So we're going to plus or minus 6.4, and we're going to rearrange them. We're going to pull out the negative 1 right here. We're going to cancel out the t minus 6.4s. 4.9 divided by negative 1 is negative 4.9. 6.4 plus 6.4, we plug that in. Times 12.8. Still follow me? And you get negative 62.72 meters per second. So that's how fast it's going when it hits the ground. Not nearly as fast as the other one. That's why at only 200 meters, it takes just as much time. The other one was going over twice as fast when it hits the ground. So, all right, probably not as heavy as a wrench or something like that. Got it? So anyway, that completes evaluating limits analytically. So now hopefully you'll be able to do all the stuff. This is the most important part of chapter 2.3. If you can evaluate limits analytically, that is pretty much all you really need to do. What we're going to throw in after your next test, which is going to be just on this, is going to be one-sided limits and limits at infinity, which is a lot easier to do. But like I said, this is the basics of all limits that you need to know. That's why we focused a lot on the information involved. All right. So hopefully you can use all this stuff now. You know how to find limits of trig functions. You know how to find limits of radicals. You know how to find limits of basic functions. So you're all good there. All right. So till the review, I'll see you next time, and I'm glad you're doing well. Hopefully.